Aigi Ming Irengbam Lenin, I'm a class 9 chemistry takani. Hello, my dear student. Today we are going to learn a new chapter, chapter number 5, and the topic is structure of the atom. No chapter ni akoi na log khat tuise aduga chemistry gi oina di koi aroi ba chapter ni ko aduga topic sina structure of the atom ni akoi chapter si gi hodringa da akoi hana khongna se madudi chapter sing gi mamang da togi chapter sing do ko akoi na we have learned that matter is made up of molecules which in turn are made up of atoms na ko tangre haibadi kaino matter sing je molecules na sai na mu hai gre ko ado molecules ji amu kana rong sai atom sing na mu sai na ko khangre ade matter sing je makhalam ta mana de ko makhal kya gi matter myam le ko ado makhoi sing je kai na ohen mano mana da se kai na ohen mano have the yauri ba makhoi sing je sarak pa da changi ba ko na sai gi matter du sa da changi atom sing je mana da na ohelak ne ko ana so in akoi chapter sida is the asigi structure of the atom ja masi chapter ja holdringai is the structure of the atom ja laktringai is the akoi kai mind to na akoi atom gi structure si la e haibagi ko akoi history khra chu ong gi mina si ko masi khangmin khangdaba yadam ni history se atom gi structure si la koi history je khangdaba yadam ni yahanam da koi aham scientist ko Michael Faraday have scientist se masi sigi matang yeng chi mahang na harame for the first time establish relation between electricity and matter ko mahan ihan hamba establish to mani relation between electricity and matter have ko he stated that electricity is made up of particles ko particles called atoms of electricity have particles things na ko ngasagi electricity have se ko sai have ni have cham badi kaino atoms electricity gi atom sing na electricity have se sare e have ni ko in 1830, that Michael Faraday showed that chemical changes occur when electricity is passed through certain solutions, such as water containing little acid. Mahana experiment kai experiment have ising the acid khara yaw ising the ko mahana akoigi electric current thadare ko electric current pass to hom matam se ja kadoge the ising hydrogen amasong gas da decompose to he could calculate the mass of a substance produced by a given quantity of electricity api be electricity gi chang khara pichalle mana ko electricity gi quantity khara pi ba matams da ngasai gi reaction thoga puthore ba product to adugi magi chang je kayam yamna puthore I mass e kyam yam lumba oige habidi hydrogen na kyam lumino oxygen na kyam lumino habisi ma calculate to bunga mamme swain to drama na ngasai gi habidi atoms of electricity hydroma thola me ba sugaina electricity current pass to holakan da thola iba ngasai kaithare iba waters na hydrogen da kaithare oxygen gas da kaithare tan sain to na puthora pusida mana kana electricity have a atoms of electricity na semani hana lowre ko adogi in 1874 da amu GJ Stoney ko scientist amana mu suggested tawre ko madudi kaino the name electron for the atoms of electricity ngasai gi Michael Faraday na haramba atoms of electricity do JJ Stoney na mu kado GJ Stoney na kai haramba Manamo electron kawi hadama suggest however the real credit for the discovery of electron goes to J.J. Thomson J.J. Thomson the chaliko credit koigi electron putho pesi hoji yenga se adu the discovery of electron electron kamai tong puthoro kibage habase in 1878 William Crookes scientist amana William Crookes found that when a high voltage charge from an induction coil is applied to tubes filled with gases at very low pressure it resulted in the production of new kind of rays mahangna induction coil amada high voltage thajallaba or induction coil sidagi high voltage ama pithore eng khala se ko khoi thajal kanza mai thajal kanza aduga tube sida su amuk gas hape ba gas makhanna ba gas ka hape aduga kaduba aduga low pressure thamkanda Anu makhalgi kadawa rays mayam puthore eva kadai since this rays travel from cathode towards the anode they are called cathode rays ana karameva cathode rays kawi kai gi marang no ngasai rays e kadai de tholok page ha cathode tagina anode rom da chale cathode ta ki tholak aga anode ta chatpa kwa cathode ha ji kaino electron ni kwa karamba negative terminals of the electricity kwa electricity or koi ngasai battery da samjane negative terminal samiba electrode to madu koi cathode kawi positive terminal du buna koi na kedoba adugi anode tu buna anode kano electrode tu buna anode haina kawi kwa ana ngasai negative terminal or electrode cathode sidagi rays tholak paniya masigi ray sing chibu koi ma hangna kedoba cathode rays haina kaurameba later JJ Thomson na masidagi amu hena characteristic magi nainaraba amasu my constituents myam singje nainara kanda ko cathode rays se amu nainara kan se dai zamana apparatus samsu sinai ko apparatus used by him shown in the figure ko figure da utpa adum gim ni se mana kamai to da semano madu apparatus to kamai to kholi ka hai je ko adu apparatus to gi maming de discharge tube or cathode ray tube ha ga sudum khangne ko ade mahana JJ Thomson na khoi gi keno se characteristics sing naina raba matungda maana si conclusion sing la eba akoi hoji characteristics of the cathode ray se ungim na si ko according to the JJ Thomson gi experiment ki matungina maana saina harami han bada ngasai light mangan gumna ngasai gi cathode ray si su travel in straight line oi haidra mana harami ko adagi ma si gi mathangda mana experiment taw matam da ngasai ray si have the cathode ray si gi marak sadai da kai obstacle have the kai thingna posa opaque object kra object ma hapsan matam da haibo object tu gi shadow cast to ngam me ko adagi ngasai gi khoi ray sin satlingai da chumna satlingai da aina manak sa magnetic field pusala aba ko magnetic field pusala ko matam da ngasai gi chumna chalamba cathode ray se bend taw aga kadawi ma towards the kadoba ko positive lom da chatle positive magnetic field lom da chakhal e ko si singje mai characteristics ne haidana mana putho amebo ko aduna mango the credit se pia akoi ngasai electron puthok pagi ko electron na akoi ke or ngasai kadoba cathode ray sa ga sudum khangna ko matang sa the mass of an electron is nearly 1 by 1837 of the mass of the hydrogen atom wave ko the charge of the electron is the smallest known electrical charge ni khwai di pikpa ko charge haraga the electron ki charge bu khangne akoi na khudong cha na bai damangta for the convenience this charge has been assigned a value of -1 sam da khona -1 ne na dum loksan bai ai mai value se ko adidi akoi makhata na akoi amu atopa koi discovery of protons tong la si ko discovery of protons ko negative koi khanga do si kaino atom ma haiba si electrically neutral oya my charge kem like atom gi ko adu ngasai koi ngasai JJ Thomson gi matungina atom ma da negative oiba charge yaure electron yaure adu gadi atom gi charge negative oidri kai gi no haiba question je la ko adu tabudabu atom di koi neutral charge oya adu di it must contain some positively charged particles to balance the negative charge of the electron haiba ko samna haiba di akoi na khangba yare matang ja ngasai negative charge siga chap manaba positive charge ki sarup ama yangani mabani se khaidongna haiba di balance tawra kan sida ka doge da akoi gi atom se neutral oi ni haba ko positive masing and negative masing chap manara kan sida ida akoina neutral oi gni haidan lobe ko si concept sida ge kanana in 1886 the E Goldstein go scientist in repeated the cathode ray tube experiment ama halleba using a perforated cathode ko mana ngai cathode to electrode to cathode oi ba ko negative terminal sami ba cathode to adugi electrode to mana perforated have the aho bo yaw bo ko aho bo yaw bo oi ba sindu e man sindu dem kan to experiment mo halle he demonstrated that positive rays were produced simultaneously with cathode rays ko cathode rays puthokpa matam da pithore negative terminal degi kan positive terminal anode on the chale matam tangkak chap manana matam madu da ngasai perforated aho ba ka sai cathode ki electrode to adu dagi su chap mana matam du da pungham du da kedowa akhoi gi positive oiba rays myam thole eba opposite direction da kanagi opposite direction to the cathode rays ko cathode ray gi opposite oina na la eba thole eba these rays travel in opposite direction to the cathode he called these rays positive rays or anode rays ha khangna anode rom da la e ha ba na ko anode rom da gi la pagodo manana chatli haidra man madu anode rays na trakan positive rays ha tholam ya later known majsi bo khoina protons ha khangna gre ko hojiti the charge carried by a proton is plus 1 ko convenient oi na ba si jo khoi da charge se plus 1 ne dum lo re hoje makha tabs di akhoi discovery of nucleus ase ong yen se ko atom ma gi manung sidai da nucleus haiba ma saruk ama yawi haiba se puthore makha tar ko ngasai proton yawre electron yawre haiba experiment sing jagi khangba hore ko khangabni na hoji kadai de yawri no kamai to leiri no haiba mayam che ong la eba in 1896 da Henry Becquerel ko ba scientist na muk the phenomenon of radioactivity discover tore eba ko radioactive elements in the radiation tholak bagi mayam che ma puthore eba ko adai masi puthorok padai di maha akhoi scientist sing sina kaidore akhoi radioactive elements they tholaiba radiation che maming ahum thona habdi makhal ahum thona ri ahum thona khaido me alpha beta and gamma rays haiduna ko akhoi radioactive elements de ri makhal ahum thole haiduna puthore ko alpha haragana positive charge oi gadini positive charge rays ni and beta sina negative charge rays ni adu gamma di no charge ni ko moi mem imitate tore habsi matam sidagi khangmangamo e kadai degi asa Henry Becquerel na kadoba radioactivity gi phenomenon se puthorok padagi ko ade Ernest Rutherford che la Ernest Rutherford na masidagi sum khangning be henjalaktana ko mazu scientist amne mana ko kadoro ke in knowing how the protons and electrons are arranged within an atom ko man interest or kamai to protons se tham yori jano electron na kamai to arrange story jano atom amai manung da ha ma in 1991, so in 1911, in 1911, he directed a stream of alpha particles from a radioactive source towards a very thin gold foil. Thin gold foil, sanagi ma pram lo is kaigino sanas de akoi pai ke phudok pa yabs na ko mana good kano oi na akoi good metal oi bani na ko adugi low re mana lower cancer must this the alpha particles or haiba alpha rays thazal level ko radioactive element amandegi ko thazal la cancer man your is kaino anam man lo is kaino he used positive charge helium ions with mass 4 units low level of mahaki experiments dagi mahang thengnari se kari thengnage the most of the alpha particles nearly 90% de pass through the gold foil undeflected. 90% mukti have the re do 100% ni manung the 90% de karim ta thaktok ta na thaidu po thaijan yaw da na dum chat khre gold foil the pass to chat khre ko madu man u re ko deflection came later straight line dum chat khre a few of them got deflected through small angles adu khara makatang di ma angle khara da thaidok thaijan to u re thaido chat pa u re ma chaina re a very few, about 1 in 1 lakh, did not pass through the foil. La amagi manungda re la am chapai manungda amagumbai changdi kadawa foil the faudo satpa ngamdre kama back to ever sat manam back to almost 90 degrees the back to ever hal ever hana lakhum jaga Masli Rutherford na picture the nuclear model of atoms man sagal atom mangi masak che kamaina nucleus kasi kamain legi have che hape chorakom sagal there is tiny positive charge centered in an atom called the nucleus hydrogen mana haram have the kaino atom mangi maya the positive charge carry to wa apikpa saruk jaga ma yawi ha madu nucleus ko wi ana haire ko nearly all the masses of atom is concentrated in nucleus have nucleus ki arumba sina ko habidi ngasai atom du ki arumba punamak se nucleus de no concentrate to ga yawi hadna sumana haire habidi atom ki arumba se nucleus na oigani na positive charge of the nucleus is due to the protons aduga positive charge oina koi nucleus ta leiri se kana gi maru kana na ohelibno habda ngasai proton sing du ohen mani hadmo haire the electrons revolve around the nucleus in well-defined orbit and forms the outside surface of the atom. Since number 4 point the the nucleus ki chida ngasai proton lere dana proton si ki akoi bas the nucleus ki akoi bas the kadoge da akakna orbit ko orbit akakna orbit amada ngasai electrons na koi na satuna leraga ngasai atom gi structure is hagal e mapan thong gi structure is har e ham A fifth point, between the nucleus and the outer electron is empty space except for other electrons. Nucleus electron outer space the chat liba koina koriba space the kwa koiriba electron siga marak chai sa kwa ahang wanak lei haba or marak se electron kharat lei ba natana atei ngai di ahang wanak tani na hairam the size of the nucleus is very small compared to the size of the atom haba atom ga yengnaru ga di nucleus ke size se suki matak kadowa matik kadowa kupi haidana mana hairam kwa sibok ta koi nucleus ki leigre nucleus ki Rutherford na puthar koi nucleus leigre adudi masdagi akoi na khange madudi positive haibam ga negative haibam ga dil leire positive ki saruk tuna center da leire nucleus haibse leire electron ki saruk negative oibsina koina satran leire hay ko aduga atom mamma ki charge di neutral oire hay ko ana masdagi akoi na atomic number haibse mostly na in 1913 da Mana try to determine the exact number of positive charges present in the nucleus of an atom by studying the nature of the X-ray emitted when different elements were bombarded with cathode rays. Cathode rays, ma'am doesn't X-ray, ma'am doesn't know mana. Say yeng badagi di ko mostly is na 1930 dagi di ko man atomic number gi concept puthong na honareba. He stated that the number of positive charges on the nucleus increases from atom to atom by a single electronic unit. Mang na hairameba kedoba atom mamaga ye positive charge amamam khakta mana hengal e haibana mana hen haiba habde atom mamaga khenaba se positive charge ki oiba charge amamam de hena khenadi haibane ko amamam hengala chatnai haibane atomic number hypothesis dagi di kaino makoina loksale madudi number of protons ni karaida in the nucleus of an atom ni hydromoina like high level ko atomic number is the number of protons in the nucleus of an atom mana high ko discovery of neutrons the entire mass of the atom was regarded as the mass of the protons in the nucleus ko atom gi arumba haibse kanana oibage haibada nucleus ta yariba proton gi arumba dunia haidan lorme ko however it has been found that for all the atoms except hydrogen natana the atomic mass is more than the atomic number ko hydrogen natana atopa elements singji or atopa elements singi atomic mass singja kadawa my atomic number dai noi hen leirame a hen ba leirame aduedi Nasai channel is a Kudamoina Hageko. For example, atomic number of helium is 2 never. Aduga atomic mass 4 never. Other the atomic mass canary was a Karaya going aside proton gidi only 2 kitani other proton machine 2 near higher atomic numbers at 2 near haram helium. Other the Magi nucleus ke arumba 2 kitam oibum to Adum Tashang all a kind of the atomic mass 4 year. Other Skumba channel will laugh with the Kaigumba Makakange, Madudi Kaino. Atopa Posak amakha yauri kanana madune atomic mass oina pinaba have the proton gi mathakta atopa ma yauri maduba koina neutron ko neutron was discovered by kedawa James Chadwick in 1932 the man discovered the discovery of the neutrons made it clear that the nucleus of the atom consists of protons and neutrons and discovered the udaidi kadore nucleus is the proton amasung neutron yawi have a khangmanga the sum of the number of protons and neutrons present in the nucleus of an atom is called the mass number and the next term ama kharaga kitang palamge ama khakka ko isotopes and isobars haidana ama koi matang sana koi paloge ko marakta yawbani sabda koi lesson sigi isotopes asi kaino habse angtang khamina hose isotopes are the atoms of same elements having the same number but different mass number are called isotopes of the element ko atoms of same element habani element di chamana ko ama khatang oiba habani ko element aduga makoi gi kadawa atomic number sum manani ko aduga having the same number but different mass number di manadaba havni makogi arumba di manadaba ko example the hydrogen have isotope ahum leba ko akoina ordinary hydrogen dubuna protium kawe aduga ani subuduna deuterium kawe d achobuna dum represent tawi ko tritium haidna sina akoigi atomic mass number ahum oiba ko 3 oiba adu my atomic number de dum 1 oiba ko hydrogen gi 1 ja dum ojaba anu makha si magi su represent to akoi t capital T na represent to ko anu isobars hai ko isobars am kaino yengse isobars are atoms of different elements that is atoms having different atomic numbers may have same mass number mass number di manaba aduga atomic number di khenaba ko different elements oitabni ko atomic number manadra gadi different atoms ni ko maya these atoms are called isobars hayo makoina habadi mass number manaba atomic number khenaba sigi elements sing chibuna akoina isobars kawe example da carbon 14 ga nitrogen 14 ga ko makoi hai je kaino carbon 14 nitrogen 14 hai je kaino carbon gi atomic number di chamana ba ko chap manai kaino manada ba ko aduga mass number di manaba mass number ni ko 14 hai cha nitrogen is 14 hai ju mass number ni ko ana mass number manaba carbon gi di akoi kaino to idana mai atomic number se kya no hoi 6 ni ko adagi di nitrogen gi di 7 ni ko anain tawduna leigrabani na makhoi gi atomic number di manadre mass number di manaba ko 14 di oiminaba sain tawduna akoina isotopes khange ko isobars khange ko isotopes agana atomic number kedoba atomic number manaba mass number manadaba isobars agana atomic number manadaba mass number manaba ko so far in akwai ngasigi session asida akwai na tamgre madudi akwai angtang recap tawsi ko akwai kai kai tamgrage do ko akwai proton kamain puthorokpa electron kamain puthorokhiba ko neutron kamain puthorokhi discovery of nucleus kamain tawki sina chingba atomic mass adagi atomic number isotopes and isobars su khangen lawre ko sina chingba akwai ngasigi session sida tamgre ko makha ta ba session di akwai next akwai next ta mung yimina ji ko next class ta mung yimina si thank you very much